we're discussing about Bayes theorem, and I given an example also about a bike which is purchased from a showroom, found defective, and you have taken that bike to the showroom and you have shown that to the showroom people, and they have the data that this bike must be produced from different plants like PQR we have taken. Like if you take any branded vehicle, that branded vehicle should be produced from any one of the plants, existing plants in the country. Okay, so the defective bike might have been produced from any one of the plants. So in such a case, the manufacturer or the showroom people must know how many defective bikes are manufactured from a particular plant. That is knowing the probabilities of getting a defective bike from different plants like that. Okay, then in such a case, the occurrence of getting a defective bike happens from any one of the plants. So that's an example I have taken. Now, let us take a better example than this, which is practically suitable to you. You are given, let me say, you have to give 3 examinations. One is JEE examination. Another one is, let me say, WIT examination. Another one is something like some SRM university examination. You are giving all these 3 examinations. After writing the examination, let us suppose all these are online examinations. You know the marks. That after you finish the examination, let us suppose you know the marks and you know the cutoff marks also. So that in such a case, you must know the possibility of selection of yours for JEE or WIT or SRM, whatever it is. So in such a case, you want the selection in JEE. You want the selection in JEE. That means probability of selection, let me say, as A. Selection, let me say, as A. So probability of your selection for JEE, P of J, given A must be sum of all these probabilities. That is probability of A after J plus probability of V after A after V plus probability of A after S. You need this one. So which is to be taken up. That is probability of A after J, like this. Okay. Now, if you see the Bayes theorem, generally the confusion is the Bayes theorem, where it is to be applied. The Bayes theorem is to be applied whenever an incident like A happens with the different events, and we need the probability of that event to occur with a particular event. In such a case, you have to apply the Bayes theorem. Now, if you go through the definition which is on the slide, you can see that, please. That is Bayes theorem. If an event A can occur only with one of the n mutually exclusive and exhaustive events, What does it mean by mutually exclusive and exhaustive events? Nothing is common to them. Their intersection is always phi. That means that all the events B1, B2, B3, so on, Bn are mutually exclusive and exhaustive events, and the probabilities of P of A after B1, please go to the slide. Probabilities of P of A after B1, P of A after B2, and so on, P of A after I are known to us. You must know all of them. If you add all of them, you will be getting the sum of the probabilities. And what we need is the probability of occurrence of event A with an event I. Bi is defined to be P of Bi into P of A after Bi, whole divided by, this is sigma P of Bi into some P of A after BI, you can take it as R also, not a problem, because we have taken a particular event as I. This R runs from some 1 to N. N mutually exclusive events are there. So, how do you understand it? Simple. Keep the formula aside. How do you understand it? The classical definition of probability is number of favorable outcomes divided by total number of outcomes. Number of favorable outcomes divided by total number of outcomes. In this case, now it is simple, very simple. Favorable probability upon total probability. What is the difference now? In case of classical definition on probability, number of favorable outcomes for an event to occur, whole divided by total number of outcomes in the classical definition. It is modified like this. Whenever a particular event is occurring with different events, and we need the occurrence of this event A with a particular event BI, then in such a case we apply the Bayes theorem. So simple, understand like this. Bayes theorem is defined to be favorable probability divided by total probability. Whenever the case of total probability comes and you need the occurrence of that event here with a particular event, then you have to make use of this. This is nothing but the total probability. From this total probability, we take the favorable probability which is required to us. That will give you the probability of occurrence of BI after the occurrence of A. Is nothing but favorable probability divided by total probability. This is simply the Bayes theorem. So understand Bayes theorem like this. Particular event occurs with many events. Then if you add the probabilities of all of them, then you will get total probability. And if you want that particular event to happen with a particular event, then you have to take that to the numerator, which is nothing but the favorable probability. So if we take a problem on this one, you will better understand this. Now, let us take this, and proof of the Bayes theorem is also important for you in the boards level. So, you learn the proof also for Bayes theorem. It is also very simple, very simple. Now, let us see a problem now. A purse contains two six-sided dice. A purse contains two six-sided dice. Generally, the die is consisting of 6 faces only, and one is a normal fair die. Normal fair die means it has 6 faces, and 1, 2, 3, 4, 5, 6 are marked on it. They are equally likely and exhaust to events. Getting 1 or 2 or 3 or 4 or 5 or 6 are equally likely and exhaust to events. That is nothing but a fair die. Fair die. While the other has 2 1s, 2 3s, and 2 5s. Other die consisting of 2 1s and 2 3s and 2 5s. Please go through the sentence. While the other has 2 1s, 2 3s and 2 5s. Then how do you understand this? What is the probability of getting 1 on a fair die? On a fair die is 1 by 6. What is the probability of getting 1 on a fair die is 1 by 6. What is the probability of getting 1 on the second die in this case? That is a biased die. Biased die. How many 1s are there? 2 1s are there. How many total number of outcomes are there? 6 are there. So it is 2 by 6. Do you find the difference? On a fair die, getting 1 is 1 by 6. On the biased die, getting 1 is 2 by 6. Understand that. A die is picked up and rolled. A die is taken and rolled. Then, because of some secret magnetic attraction of the unfair die, because of some secret magnetic attraction of unfair die, there is 75% chance of picking the unfair die. Understand that. The secret of attraction makes it possible to attract or to pick up the second die only more. What is the second die? Second die is an unbiased die. It has 75% chances to pick up. Generally, how do you see this problem? When you have 2 fair dice, picking up 1 die or picking up 2 second die, what happens? The equal chances will be there. That is 1 by 2 is the chance to pick up the first die. 1 by 2 is the second chance to pick up the second die. But in this case, these are biased due to magnetic attraction. The second die can be picked up in 75% ways. That is 75 by 100. means 3 by 4. So picking up the fair die is only 1 by 4. That is the data given. And the die is rolled and shows up the phase 3. Die is rolled and shows up the phase 3. Die is rolled, die picked up and thrown, and it is showing the phase 3. Okay. The probability that a fair die was picked up. The probability that a fair die was picked up. Let us apply now the Bayes theorem. See. Now let me say here, in this case, A, getting 3. Getting 3. B1 is fair die. And B2 unfair die. Okay. What is the probability of B1 fair die? No? So getting 3 is 1 by 6. What is the probability of getting 3 on the unfair die? It is nothing but P of B2 is nothing but 2 by 6. Understand? Why 2 by 6? 2 3s are there. You can see the problem there in the second sentence. The second die has 2 3s. That is why it is 2 by 6. 2 by 6. Now, what is the probability of picking up? What is the probability of picking up the first die? It is P of B1. What is the probability of picking up the second die? Second die is 3 by 4. 3 by 4. Understand that first. Now, let us write what is required there in the problem. The die is rolled and shown up the phase 3. It is given that it is just shown up 3. So, we have written the probability of showing up 3. Now, the probability that a fair die was picked up. Probability that a fair die was picked up. Simple. Always remember, fair die is this one. So, it is to be written P of B1 after A. P of B1 after A is written here. So, what do we require? Probability of A intersection B1 union A intersection B2. What does it mean? Either getting 3 may happen with B1 or getting 3 may happen with B2. That's what I have written here. A, that is getting 3, may happen with B1 or ORR. This is union. Or it may happen with B2. But what do we need? We need it to happen with B1. Okay. Now, in this case, probability of B1, let me write this in this way, A after B1. A after B1. And this one is A after B2. Okay. Now, what should it be? What is A? Picking up the fair die. B1 is picking up the fair die. Picking up the fair die is nothing but it is 75% chances are there. You can see that 75% chances to pick up B2. So that is why 75% means you can understand it is nothing but 3 by 4. 3 by 4 for B2. But for B1 what happens? It is only 1 by 4. 1 by 4. And what is getting number 3 on this one? 1 by 6. This union stands for plus. And what is the probability of picking up B2? B2 is here 3 by 4. And what is the probability of getting 3 on B2 is 2 by 6. So what we wrote here, we have written the total probability first, and from this one we are interested to get the number 3 from the fair die. Fair die. What is the probability of getting number 3 on the fair die? It is this one, which is nothing but the favorable probability. 1 by 4 into 1 by 6. 1 by 4 into 1 by 6. So what should be now? The 6 into 4 is LCM 1 upon, it is 1 plus 6. It is, if you simplify this, you'll get the answer. It is nothing but 1 by 7. I repeat the problem. This is A getting number 3. B1 is the fair die. B2 is the unfair die. So A happens with the 2 events here. What are they? B1 and B2. So what is the probability of B1 picking up B1? Let me write that also. picking up B1, because you can understand that I didn't write that. P of B1. And what is the probability of picking up B2? Probability of picking up B2. B2 means it is given that it is 7, due to some magnetic attraction, it has 75% chances. So that is why it is 75 by 100 is nothing but 3 by 4. When it has 3 by 4 chances, it will have 1 by 4, obviously, because only two exhaustive events are there, B1 and B2. The sum should be 1. So if it is 3 by 4, that should be 1 by 4. Now let me apply. What is our requirement here? The occurrence of event A, that is getting number 3, must happen with fair die. That's what we want. But the occurrence of event A may happen with B1 or may happen with B2. That is why I wrote both. That or. This becomes plus. And what is P of B1? What is P of B1? It is 1 by 4. Conditional probability, please. Conditional probability, it is nothing but 1 by 4. What is the occurrence of getting number 3 with the B1 is 1 by 6. 1 by 4 into 1 by 6. And it is nothing but 3 by 4 into 2 by 6. What we need is, it must occur with A. That is why it is sent to the numerator. 1 by 4 into 1 by 6. Now if you simplify this, it is 1 by 7. This is nothing but the Bayes theorem. Very simple. It is important for all the boards. If you check out your CBSE textbook of probability, then you will have a separate exercise on Bayes theorem, which is very simple. So simply see the Bayes theorem in this way: favorable probability divided by total probability. This is nothing but the Bayes theorem. So what I wrote from this one, this is total probability. What I require this one as favorable. That is why it is sent to the numerator. So this is what the application of Bayes theorem. Next problem, please. See. Please go through the slide. All of you, please read it out once. Read it out and you will understand in a better way what is given there. So on a Saturday night, 20% of all drivers in USA are under the influence of alcohol. On a Saturday means weekends, because they are all weekends. Saturday, Sunday, they used to take alcohol. So the data given that 20% of drivers in USA are under the influence of alcohol on a particular Saturday night. Next, the probability that a driver under the influence of alcohol will have an accident is 0.001. The driver under the influence of alcohol will have an accident is given to be 0.001. The probability that a sober driver will have an accident is 0.0001. If a car on a Saturday night smashed into a tree, the probability that the driver was under the influence of alcohol is. So here two cases are occurring. Number one, the driver without alcohol, without taking alcohol. Number two, the driver taken alcohol. Two cases are there. So whenever drivers are of two types, one is under the influence of alcohol, another one is not under the influence of alcohol, then the accident may happen with the first driver or it may happen with second driver. So what is required there? We must know the probability that the driver was under the influence of alcohol. So here understand that what is A here? Simple. You can write it in one step. What is required? Here Bayes theorem says that required probability is nothing but favorable probability upon total probability. Because these are the objectives. If it is subjective, you have to write all the steps. You have to consider A, B1, B2, B3. If three events are there, you have to write all of them. But because it is objective, have more you have to have more pace while working out the problem. So simple thing, the moral of the Bayes theorem, the story of the Bayes theorem is nothing but total favorable probability divided by total probability. So what I'm doing now, I'm taking first of all total probability. How many drivers are under the influence of alcohol? 20%. So 20 by 100. I have written that. We have chosen the alcoholic driver now. Next step. The driver under the influence of alcohol will have an accident is 0.001. That is 0.001 plus. That means now it is the accident occurred due to the driver under the alcohol. Okay. Next. When 20% are under influence of alcohol, obviously 80% will be out of alcohol. That means without alcohol, without taking alcohol. Into, because of these drivers who are non-alcoholic, what is the percentage of getting an accident is 0.0001. You can see that clearly, please. Please see the data, 0.0001. 3 zeros are there. Okay. Now, what is our favorable probability in this case? What is a favorable probability? You can see the question that the probability that the driver was under the influence of alcohol. Why two cases here? It is under influence of alcoholic and it is not under the influence of alcohol. Which one we need? We need this one. We need this one. That is why it is favorable. Get it to the numerator. So it is 20 upon 100 into 0.001. That's all. If you simplify that, you'll be getting the answer. It is simply, let me write in this way, 20 by 100 and it is 0.001 means it is 1 upon 1000. It is also 1 upon 1000 and it is 1 upon 10,000. Okay, now let us simplify this. Let us take this one common, 20 by 100 into 1 by 1000 common. Then you will get 1 upon, getting cancelled. This is 1 upon 1 plus 20 taken common, 4 upon and 1000 taken common. So that is why it is only 10. So what should it be? 10 upon 14. 10 upon 14 is nothing but 5 upon 7. See the option there. It is option 3. Option 3. Okay. Let me explain you again. First of all, whenever you have these many concepts in the probability, how to understand first, after going through the problem, how to understand that Bayes theorem is to be applied first of all. So that's important thing here. Because getting an accident or to have an accident is now divided into two cases. What are two cases here? With an alcoholic driver, the accident may happen. With a non-alcoholic driver, the accident may happen. So in this case now, he has to give us the getting an accident with an alcoholic driver. The probability must be given. That is given clearly. You can see that. That's given. And in the second case also, the probability must be given. That is also given. So both must be given. Then only you can solve the problem. So both are given. And what we need is alcoholic driver. That is why it is sent to the numerator. And to simplified, you got the probability of getting an accident with an alcoholic driver. Okay, so this is the Bayes theorem. Please go to the next slide. Yes. The ratio of the number of trucks along a highway on which a petrol pump is located. Okay, a petrol pump is located on a highway and the ratio of number of trucks to the number of cars running along the same highway is 3:2. Is 3:2 means first trucks are given, next cars are given. So getting a truck, if 3 trucks are there, 2 cars will be there. If 3 trucks are there, 2 cars will be there. So probability of getting a truck is 3 by 5 and probability of getting a car is 2 by 5. That must be given. Okay. Now 3:2. So, I repeat the sentence. The ratio of the number of trucks along a highway on which a petrol pump is located to the number of cars running along the same highway is 3:2. That's what I have written here. 3:2. It is known that an average of one truck in 30 trucks, and 2 cars in 50 cars stop at the petrol pump to be filled up with the fuel. So, how many trucks will be there filling up the petrol? The probability is clearly given. Average of 1 truck in 30 trucks. Average of 1 truck in 30 trucks is given. And similarly, 2 cars in 50 cars. 2 cars in 50 cars to fill the petrol. Understand that? So, whenever you work out this problem in the board level, you write all the terms, you name the events, and you solve it accordingly. But in the objectives, try to save the time by writing the direct steps. What are the steps required in this case, and how to get that the Bayes theorem is to be applied in this case? Because the question you can see now, if a vehicle stops at the petrol pump to be filled up with the fuel, find the probability that it is a car. So whenever in a petrol pump, 2 types of vehicles are entering. One is a truck, another one is a car. So filling up of petrol happens in 2 ways. One is filling up the truck, and another one is filling up the car. So 2 events are the filling up of petrol is happening with 2 different vehicles. That means the happening of petrol is happening, the filling up of petrol is happening with truck or car. That is why the total probability comes now. The total probability now getting a truck into the petrol pump is 3/5 into 1/30. Simple. Favorable probability will come to the numerator, total probability will come to the denominator, plus, and getting a car is 2/5 into 2/50. 2/5 into 2/50. And what is the question there? Find the probability to be filled up with the fuel to be filled for a car. For a car we require. This is for a truck, this is for a car. So it is 2/5 into 2/50. So what should it be? If you simplify, you will get that it is 5 into 50. And let us take 4 upon, it is, if you simplify this, you will get the answer. So that's it. You can try this now. The simplification part, it is easy for you. You can note down the options and you can get the answer. So by Bayes theorem is to be applied whenever a particular event, filling up of petrol in this case now, is happening with a truck or a car. R stands for plus. Now it should happen with a car. So probability of getting that particular event is taken like this. Favorable probability divided by total probability. Simplify this, you'll get the answer. Okay. Now let's see on the problem. Yes. During a power blackout, 100 persons are arrested and suspect of looting. During a power blackout, 100 persons are arrested on suspect of looting. Each is given a polygraph test. Polygraph test means from the past experience. Let us see what is a polygraph test. You know that. From past experience, it is known that the polygraph is 90% reliable when administered to a guilty person. The polygraph is reliable when administered to a guilty person and 98% reliable when given to someone who is innocent. Suppose that of the 100 persons taken into custody, only 12 were actually involved in any wrongdoing. Only 12 are suspicious. That means 12 are guilty. Only 12 are guilty. Means what? Only 12 are guilty means 88 are innocent. 88 are innocent. That is the data given there. 88 are innocent. So, if the probability that a given suspect is innocent, if the probability that a given suspect is innocent, given that the polygraph says he is guilty, is A by B. Is guilty is A by B, where A and B are relatively prime numbers. Find the value of A plus B. So, understand that during a power blackout, 100 persons are arrested. What we require is simple favorable probability upon total probability. What is favorable probability there? Before writing favorable probability, always I am repeating that whenever you work out the problems based on probability, always write the denominator. What is the denominator? Total number of outcomes. In this case also you have to write total probability. If you write total probability, then you will understand in a better way what will be our favorable probability. That is why try to answer the probability questions first of all by finding the denominator, which is denominator according to the classical definition on probability, total probability. So what is the probability here? So it is guilty. Let us write first guilty person. So guilty person is 90% reliable. Whenever polygraph is applied, it is 90% reliable. So 90 by 100. So according to the data, you can see that only 12 were actually involved in any wrongdoing. Only 12 were involved in any wrongdoing if 100 persons are chosen. So it is 12 means it is 12 by 100 into 90 by 100 plus what should be the reliability if it is applied to an innocent person is 98 by 100. When 12 are found to be guilty, remaining people must be innocent. So, what is given there? It is if the probability that a given suspect is innocent, given that the polygraph says he is guilty, is A by B. It is found to be guilty. This is innocent. So, this part 88 by 100 into 98 by 100 is found to be guilty. So this is given to be A by B. This is given to be A by B. Then in such a case, what should be the value of A plus B? What should be the value of A plus B where A and B are relatively prime numbers? What are the relatively prime numbers? You just think of it, and if you understand, if you answer the question, write the options there. 177, 178, 179, 180 are the options given there. You understand it, you try this problem. If you know what is the meaning of relatively prime numbers, what are the relative prime numbers, if you know, that will be better. Otherwise, we will see that in the next session.